name is Keremedjiev, and don't panic when you see it. If you read every letter one at a time, don't rush, you'll be fine. So this is how we start with that one. And I am very excited to be able to start talking about the Enigma machine. This is such a fascinating story, and so many interesting aspects to it. Oh, I'm sorry, I should have been talking to the microphone. Okay. And I will welcome some questions afterwards. So we will start with, let's see if I do it right. Yes. This is not a typewriter, okay? Looks like it because it has a keyboard, it's portable, it is pretty small, and yet when we start adding all the combinations, all the possibilities that this small machine can wreak upon us, the numbers are beyond staggering, and we will be talking about very shortly. And since Liz mentioned codebreaking, cryptology, spies, all of this is part of this presentation. And of course it starts very, very early on. Pretty much with the beginning of writing, we had the beginning of code. That's pretty much how it goes. As soon as we had the writings, we had codes. We were writing so we could hide certain information. There were quite a few of those. It dates all the beginning, like I said, to the beginning of writing. In fact, some of the carved hieroglyphs that were coded were found in 1900 BC in Egypt, in 1500 in Mesopotamia on clay tablets, and part of it was a secret recipe for the pottery glaze. Then, of course, in 400 we had in India, including Kama Sutra, not to mention ancient Greek and, of course, Rome. And then it went to Middle Ages. Arabs were the first in 1800 to start really systematically codifying and understanding how the cryptology, how codes work. Then, of course, we move into Renaissance, where it was absolutely paramount. Half of the kings of England and queens of England were beheaded because their codes were broken. Make no mistake about that. And so that was part of it all the way through World War II, where the code breaking was really mathematically inclined and really developed very nicely. All of this for us starts in the year 1918. American Edward Hepburn designed this machine, and this again looks like a typewriter. It's built out of solid brass, has mechanical parts, but inside there is a rotor or a wheel, and inside that wheel there are 26 letters, codes for letters because it's electric, and on the other side another 26 letters, and contacts connected inside. You cannot see it, but that's what it is. So inside there, each letter can be connected to another letter on the other side of the wheel. So this is the scrambling, the first scrambling process. The machine actually was, oh my God, what happened here? Well, we missed something, but nevertheless, we're good. The machine was actually designed for commercial use. And for a period of time, it was used on that purpose. The same year, 1918, in Germany, Arthur Schrebius also designs and applies for a patent for a very similar machine, which has the keyboard and the cipher routing wheels inside. Again, the whole process, as you see, you can see those three wheels here. Hold on, if I can do that. Where's the... Where's that? Liz! Okay, I think I found it. I found it! So as you can see here on the pattern, the three wheels, the keyboard, so this is the Schrebius machine inside. And again, the design was strictly for business use. Alas, in 1926, German Navy acquired the rights to it and use it specifically for military purposes. And very shortly after that, other German services were using Air Force and Army as well. So, this is what it looks like. I'm trying to point out to the few things it has. Like I said, it has a standard keyboard. Above it, it's another keyboard. This is the answer. Once the whole coding occurs, which we'll walk through, then the answer or coded message appears lit right here on this keyboard. You've noticed here there are 3 rotors or 3 wheels inside that are changed daily. And of course the order of rotors is very different as well. And then below is a plug board that could be scrambled as well. So if we start with rotors, this is blown up rotor, and you can see that on each side there of the wheel are contact points. You see the contact points wired on one side? There is 26 letter on this side and 26 letter on that side. And you see how scrambled the connections here are, okay? So that's the first step. Then there are those little notches here that determine what will be the order, how will you start programming or coding it. It could start with, number 5, 6, 7, or 8. It depends. It was daily change. That's how it was. And then, let's see. And then, as I mentioned earlier, standard keyboard, and then keyboard that once it's coded will show you the answer. Like I said, each rotor on the periphery also had those notches to set it on the daily setting. Now, the next part is a plug board. As you see, there's 26 hold sockets and 13 dual socket cables, wired cables. So you can wire this any which way you want to, connecting any possible combination of letters. And then finally, which is not visible, but it's up above, after the rotors on the left side is something called a reflector. And this is a plate with 26 points on just one side. Once the whole process goes through the rotors and through the letters, reaches the reflector, is returned back in a completely different way, okay? So, if we start to think about the number of variable connections and variable things that can happen, once you start plugging it all in, the numbers are starting. Let's start first with the electrical path taken from the keyboard. Oops, I'm sorry. Oops. What did I just do? Oh my gosh. Did we lose it? Okay, there we go. I'm sorry. Okay, so the first part is you type the letter, and this would be plain text, the message that you want to send. We received the shipment yesterday, okay? So this is all in German plain language, so you start typing like you would start on a regular typewriter. So, and it's all electrical pattern, electrical current that carries it. So you start right here with letter T. That electric current flows through the plug board, okay? As we mentioned, which is scrambled, and that letter T becomes letter K when it comes out. Then it goes through the static wheel and to the first wheel on the right. As it enters as letter K, because of the scrambling inside of all the wires, it comes as letter O. Then it jumps, the electric current jumps to the second wheel as the letter O, but of course it comes through scrambling as letter P. That letter P jumps to the third wheel as letter P and comes as letter H. Then this letter H is reflected through the reflector, and the pattern returns through completely different way, okay? So D becomes G, G becomes R, R becomes W, W enters and then becomes H through the blackboard, and in the end is lit as a coded letter G. Okay. All right, so that's what we need. And now, if we start to count the number of combinations all around, first of all, we have 3 rotors, okay? 3 rotors with 26 letters each, right? And they can be in any combination at all. It will be 1, 2, 3, 1, 3, 2, 2, 1, 3, whatever it is. That could be the combination of setting those rotors to begin with. So the starting position gives us number of combination at 17,576. That's just the rotors before we start typing, okay? And then, when we reach the blackboard, just the blackboard, with the first keystroke, passing through this blackboard, and 26 letter and all the combination, the number is, brace yourself, I'll read it out, okay? It's 500, 322, 985, 208, 200, 576 combinations, okay? So, the setting of this machine, of course, let me see what I have not quite yet. Okay, the setting of the machine is preordained. They had a sheet. Each operator and each receiving operator would have the sheet. The whole military had the same set of numbers. That's the only way you can read the messages. And that's what's called daily key sheet. And it was issued per month, 1 per month. And of course there was the day of the week, there was the order of the rotors, there was the ring position, there was the blackboard connection, and then the message key to start the whole process, okay? So, entering to the cipher machine, to the cipher, of course, the receiving clerk had to have exactly the same information, except that he would start typing on the keyboard with the coded letter. So he typed the coded letter, which would be G, and then the whole process would reverse, and on the lit, he would get the letter T, the actual letter that was in plain text. So, but as you understand, everything, if you missed anything by a notch, you're done. Okay? So it cannot happen. So it was exceptionally difficult. The number, of course, each military service has their own lists and numbers, but they were specific for that part of military. So just mention some numbers. If you add all of those combinations, the number of combination possible by Enigma configuration is 3 times 10 to the power of 114. I'll show you later. Keep that in mind, because this is the bigger number than the number of atoms in an observable universe. That's the number of combination you can have, okay? Now, how do you break it? How do you possibly break it? Well, we'll be talking about human nature a bit, okay? Of course, there are spies, right? So that's where we start. The human element is always part of every failure or success, right? So, as I always say, the machine might be unbreakable. The minute people start using, chances are there of breaking it, okay? So, beginning in 1931, there was Hans Tyler Schmidt. He was the employee of German Armed Forces Cryptology Unit, and he met with Gustave Bertrand, who was a French cryptologist, and he worked for French intelligence service. Tyler Schmidt provided or sold him current German intelligence, but also communication and information of the Enigma machine, brand new Enigma machine, and some keys, but they did not include the information about current settings, okay? Bertrand was very impressed, and he showed it to his colleagues in the cryptology office in France, And they could understand how the message was coded, but could not read it. They could not get information. It was useless. He tried with British counterparts. He also went to Britain, and they also agreed with him that it's totally useless, that they absolutely cannot use it. Meanwhile, they were getting tons of intelligence information they thought would be much more important to them than this new machine called Enigma. That's when Bertrand reached out to Polish Cipher Bureau, where his documents were accepted with the greatest gratitude. And the plan was hatched on the cooperation that Poles will start working on breaking the code, and Bertrand will be supplying information, whatever he will get, from Tylo Schmidt. Okay. The reason Poles are so very interested in applying and reaching and getting that information is that although the war to end all wars just ended 15 years ago, it was so brutal, so horrendous, with such humongous losses of human life that the humanity cannot possibly imagine another war of that magnitude, right? Right. So today we of course call it World War I, right? Anyway, and Poland's, I don't know if, oh my gosh, what am I doing here? I'm sorry. I think I pushed one button wrong and then we're done. Okay, so that's fine. And Poland's geographical location, which we'll be talking and I'll show you a little bit later on, between Germany and Soviet Union has always been precarious. And so Poles were very interested in anything when it comes to breaking German codes. So 2 years prior to 1931, actually in January of 1929, an alert custom officer noticed a very big box, a very heavy box, and was about to process it when he noticed a note from German embassy not to open this box under any circumstances and return it immediately to Germany. Can you guess what happened? Really? Okay. Not only was it opened, but it was examined for 2 days by the cryptographers from Polish Cipher Bureau. Turns out this was a commercial Enigma machine, okay? The machine was packed and returned to Germany without them ever knowing that this was actually ever opened, okay? Also in 1929, the chief of German section of Cipher Bureau, Captain Maximilian Ciężki, started a brand new course at Mathematics Institute in Poznan University on cryptology and applying mathematics to code breaking. And he found 3 brilliant students who later on became part of his code breaking team. And those were Marian Rejewski, Henryk Żygalski, and Jerzy Różycki. Yes, I'm Polish. So they were just so excited to become part of it. And they started working on Enigma machine immediately once the data started coming in. Of course, the very first task was to figure out wiring of those Enigma rollers. As I showed you, there were so many of them inside. And with some brilliant analytical work and some guesswork as well, they were able to accomplish it. And so, Rejewski figured out first thing is that, which didn't have to happen, that the letters on the wheel are in alphabetical order. They didn't have to be. They didn't have to be, but they were in alphabetical order, okay? And he also figured out the connection between the plug board and the boards was also in alphabetical order, okay? So that's first help. Then the next task was to figure out the rotor settings, how they were set up. They did have a little bit of time. We're talking 1930s, early 30s, and Germans are not changing their codes daily like this do in the beginning of World War II. They're changing every few months. So they had some time to do the mathematical calculation and figure out how to do it. So each German operator first would start with this setup sheet, as we thought. Figure out the rotors, figure out the codes, and then start the coding. And the first one was 3-letter setting, okay, to try and make sure that this is correct. And just to be on the safe side, they send it twice. Uh-oh, that's a no-no in cryptography, okay? Because that gave Paul's immediate information that the first and the third letter were the same, second and fourth were the same, and the third and sixth were the same. Nice, okay? And then each German operator, through open arrows, would set another set of 6 letters, or 3 sets of letters, to start the code. And they could choose. Of course, they have to code it again, you know, so there was like, and I don't have a photo for it, I really don't have, but, okay, what is it? 3 letters. Anyway, so, bottom line is that they would choose their own words. And of course, you know, if you have to do it daily, you get lazy. Maybe they used the word Heil Hitler. And there was one in particular that used the name of his girlfriend, Celie. So, after that, whenever they come across an easy code that they could immediately see, the name for this was Celie's. Okay? But of course not all of them was easy to decipher. Their work was pure analysis and comparison. Another aspect of it was Henry Żygalski noticed a quirk in rotor settings when you were setting it up, that every 8 insert, about intercept, the Enigma machine would repeat the same letter twice. They call it females. And that was one of the first ways to start reading or understanding the code once you have that letter. Every letter, every step helps in the long process. So Żygalski designed the sheets. They were called after him later on Żygalski sheet. And they consisted of stack of papers with perforated pages. And when they were cut to a certain pattern, they could be lined up and allow for the females to occur, so they could actually get those letters that were repeating themselves, and they knew what those letters really were. It was exceptionally time-consuming and laborious process, but once it was completed, the comparison was very easy and pretty fast. Until, of course, the Germans changed the code again, so that's, of course, the part of it as well. Meanwhile, in 1938, Rejewski designed and invented an electromechanical machine that through brute force could figure out the setting of the rotors, the 17,000 rotors, the 17,000 combinations that we're talking about. And the name of the machine was Bomba. So in Polish, that it does mean bomb, okay? It's Polish spelling, it's Polish words pronounced the same, Bomba, with the A at the end. And it was called Bomba Kryptologiczna, or cryptological bomb. And it was manufactured by Polish radio company, and as you remember, the way it was set up, there are no photos, of course, they don't exist, you know, and I cannot draw to make it, so, so you have to use your imagination. As you remember, 3 rotors with 26 letters each on each position, and that was what the 17,000 things were for. And then, in 1938, mid-1938, it ends. What happens is that in March of that year, 1938, Hitler annexes Austria, a few years later, Sudetenland. So they are now on war footing. They completely changed the timing and frequency of changing the codes. Also, they did something else. They added 2 extra rotors to combination. As we said, there were a choice of 3 rotors, and that's all they had. They added 2 extra ones. And that already includes the number of combination exponentially again. And Poles cannot build those machines. They cannot accomplish that. Also, they know that the war is imminent. They were reading enough messages to understand. So so that was the 3-rotor machine, and where were we? Oh, not quite yet. So what happens in July of 1939, British and French military or cryptology services come to Warsaw and actually spend some time with Polish cipher officers. This is the first time they understand how much Poles were reading, how many information they get, and all the tasks and all the help they could get. So it was all given to them, including, of course, the Zhigalski sheets, bomba designs, Enigma replicas. So they left. And guess what? It's only a week later that Poland is invaded by Germany. Okay? And that would be the beginning of World War II. And so the success from 1932 to 38 was astonishing. But after that, the frequency of changing the codes was just too much to handle. And so I think this is not the right one. Not the right one. Yeah, this is the old one. I'm sorry. I'm trying to get it. I'm sorry. I don't have the maps. Okay, so that's too bad. No, this is the old one.
Would you like
This
me
is
to?
the old one, yeah. I'm sorry. Okay, I adjusted it and.
Do you want me to pull up the drawer?
Yes, please. I'm sorry. You didn't see the maps, right?
Yes, I'll try to do it.
Okay, thank you, I'm sorry. Is that flipping or not yet?
Yes, you can start.
Yeah, there were the photos that were missing, so I was... there we go. Okay, thank you so much. The reason I insisted on having those maps is just to give you some idea of the position of Poland. The first map is 1933, and you see to the west there's Germany, to the east there is Soviet Union. So when in 1939 Poland is invaded on September 1st, as you can see right here, from Germany. 2 days later, both United Kingdom and France declare war on Germany. That was the previous agreement with the Polish government when they were invaded, that the World War II, or the war, will start, which was September 3rd. Meanwhile, only 2 weeks later, Poland is invaded from the east by Soviet Union. So, that was all agreement between Molotov and Ribbentrop. So this was the Soviet Union and Stalin and Hitler and Germany. They had this plan since August 1939. So now you see that Polish cautiousness and understanding that we are in very precarious geographical position is proven without a shadow of a doubt. So that was the beginning of World War II. And then, okay, now I can move here. Okay, we have the two photos, that's fine, we can work with that. So we talked about the Polish contributions and how it all evolved. Meanwhile, of course, in July, what is this? What is the text?
It's in presenter mode.
Yeah.
Sorry.
Can you put it in the...
Yeah, let me try to.
So sorry.
You maybe can right click and it gives you a choice.
No, that's right. The last one.
Working at the computer museum does not...
Excuse me, the keyword is museum. Old, past, nostalgia. Okay, we got it? Good. Oh, we can use the old one. I'm just fine. I'll make it. I'll make it. You're almost there. You're doing so great. Okay, thank you. We got the maps, the rest I can do. It's totally fine. I'm totally fine.
I present this week, wonderful.
Okay.
Yeah, so you might have to advance it to.
I'm sorry, what?
I think you'll have to advance it, so.
Okay, can we do right now?
Yeah.
Okay. Perfect. Thank you so much. See, review. We got through the review. Okay, we're at the right place. We're in England, okay? The year is 1939. And what happens, Britain, just like Poland, realized that the way to code breaking would be mathematicians. And with the declaration of war on September 3rd, 1939, they are setting up a new headquarters in Bletchley, which was the Victorian manor on the outskirts of London. And that's where there's a full name, the Government Code and Cipher School, that was the name. And in 1939, all of their mathematicians and code breakers start arriving to this location. And all of them received briefings on the work of Polish Cipher Bureau and mathematicians, and under Alan Turing leadership, began work on Enigma code. Again, it was a pre-order machine, which was pointed out in here, and the setup, we talked about it, so I don't have to come back. But theoretical number of combination, when you add it all together, would be, yes, I got it, good. Look at that number. Okay, look at that number. This is approximately 3 times 10 to 114th power, okay? So that's the number of combinations, with this little machine, with the keyboard and rotors, right? It all adds up. And think in mind that the estimated number of atoms in the entire universe is actually 3 times 10 to the 80, we missed 3, okay? Anyway, so that was what the numbers they were dealing with. So every little step they could remove some steps, some problem, and move forward was beneficial. So in 1940, Alan Turing began to work on designing the British Bomba machine that would work actually with assumed text and run through all possible settings until it reached in plain text, until it reached the answer and would stop. So that was his design. And also, in Bletchley Park, another brilliant mathematician, and that was Golden Wirchman, began working on reinventing Zhigalski's sheet, but for 5-rotor machine. But even more importantly, he devoted his time to deciding how to decode the plug board itself. And he figured out how to do it, and it was called diagonal board. Again, no photographs, no paintings of that one exist. But that, coupled with Turing's design and Turing registers And Welchman's design created the terrific design for the new machine that could help with code breaking. It would decrease the possible number of settings of the machine to only few. This was such a huge engineering challenge, and it was turned to Harold Dock Keane with the British Tabulating Machine Company, or BTM. It took months to design and build it, and the first machines began to arrive at Bletchley Park in August of 1940 with the now new name, Bombay. So this was the name for the new machine, and that was designed by Alan Turing. And as you can see, these are stacks of, each one is a 3-rotor Enigma machine, and there's 12 of them. So together there's 36 of them. That's what the combination they have to run through to figure out what the setting for the date might be. And each machine was weighted about a ton, stood 6 feet tall, 2 feet wide, and was 6 feet tall. I think I mentioned that. Now, so after they figure out how this was working, British cryptanalysts were actually successful in beginning to read the German Army and Air Force codes. They were able to read those, Army and Air Force. Navy, on the other hand, was a totally different story. It was run by Admiral Dönitz, who really kept his Navy under very tight control. And they adhered strictly to all the rules, to all the secrecy, and to top it all off, they had 3 extra rotors, for 8 rotors altogether. Okay, so that's a bit hard, okay? And they are working feverishly because this is, of course, the time of Battle of Atlantic. What you have to understand, with the fall of France in June of 1940, England is completely cut off from the continent, from all the supplies. So all the supplies are arriving from the other side, from Canada, of course, and secretly from the United States, right? The United States is not part of a world war effort yet in 1940. And so, and they are really decimated. They don't know, they don't have a convoys to support them, they have no codes. They are absolutely ready for the picking. So it was the most brutal time in the 1940s with those convoys trying to reach England, who desperately needed all the supplies they could provide. So you understand there was some urgency in figuring out how to read those messages. They started getting small breaks. For example, in February of 1940, they captured U-93 U-boat, and they got rotor 6 and 7. A few years later, they captured another one with rotor 8, but this still was not helping them with this brutality of the attacks by German submarines. Until May of 1941, so that's how long it took, when the British ship named Bulldog actually was capable and boarded the U-110 U-boat. That's very important because this was a jackpot. They found books, charts, logs, equipment, but most important, Enigma code breakers, instructions, key lists for all German Navy and submarines, plus actual 8 Enigma rotors. Okay, do you think the field has changed slightly? From that on, this was such a huge help that of course it changed. So they were able to protect and understand and see where the attacks of U-boats might be occurring. Well, Admiral Dönitz noticed that, okay? he noticed that all of a sudden he's acquiring tons of losses. But when he contacted German High Command and asked, is there a possibility that they broke Enigma? Absolutely not. This is unbreakable code. It could never, ever happen. But you also have to understand that Britain went to all kinds of lengths to protect that information and make sure that they didn't know that that U-110 boat was actually boarded. All the information was that it was sunk before they could absolutely do it. So, and Germans truly believed that to be the case, and yet the losses were staggering. So as I said, the battle shifted, and Britain also was taking tremendous precautions not to let Germans understand and figure out that the German code is broken. So every attack on the submarine had the second source. So they could always claim that the only reason they sank that particular U-boat because, for example, there was a reconnaissance plane and saw it, and that's why that particular boat was sunk. Never, ever in the whole war did they attack just by simply knowing the code. They always had to have a second source to make sure that Germans don't know that's what they're doing. Well, Dönitz doesn't take it, and he's pretty upset, and comes up with another idea. He is introducing a 4-rotor machine. Okay? 4-rotor machine. He couldn't redesign the whole machine, okay? He cannot change those settings, this is just too complicated. But he's adding the 4th rotor right at the very end before the reflector, and this is movable. So if some of the services don't have a 4-rotor machine, they still can operate as a 3-rotor by removing the 4th one. And yet, the German Navy is using 4 rotors. Guess what happens? The shipping lanes are again bloodbath for allies. They cannot read it, they cannot break it, they don't know how to possibly do it, it's just too complex, okay? And although Brits start working on a 4-rotor machine, this is exceptionally complex. So now we're joining Americans. Of course, Americans are part of Alliance since Pearl Harbor, since December 7, 1941, we're talking 42. So they all are started working aggressively to also help with this system because these are American ships. They're being, of course, decimated because of the shipment. And so in 1942, in March, Navy, in March of 1942, Navy contracted National Cash Register Company in Dayton, Ohio. They had a lot of work done on machines and wiring and counting machines or calculating machines. And asked them to start working on a 4-rotor machine. This task fell to Joseph Desch, who was the research director of NCR. And the work began immediately. And in August of 1942 showed enough promise that they started production of the American bomba machines that could design 4-rotor machine. He designed electronic accumulator. He designed electronic accumulator where for the first time numbers were counted electronically using vacuum tubes, which made the code breaking much more significant, much more reliable, and significantly faster. So in 1943, the personnel begins to arrive at the Dayton, Ohio NCR headquarters. Work was so tedious, so time-consuming. They were working 24/7. They had to wire individual rotors, and then tens of thousands of those rotors had to be wired together to create these bomber machines. So requirements amazing. But in May of 1943, they conducted a successful test. So the information was through secure line from Dayton to Washington, D.C., when cryptographers can actually read it. So by the summer of 1943, the tides change again. All of a sudden, again, Allies are successful. And they're targeting very precisely, with pinpoint accuracy, all the German Navy ships and submarines, but they particularly focused this time on the tankers that were supplying the submarines with their fuel. So this American bomb, as you see, looks a little bit different than the one that, the 3-rotor one in Bletchley. It was 7 feet high, 10 feet long, 2 feet wide, weighed 5,000 pounds, and front and back had the columns of rotors, as you can see, 4-rotor machine, right? You can see these were the 4-rotor machine designed to break the code. But then what happens, because it's electronic, when the machine reaches actually the answer, it goes too fast and cannot stop, okay? So Joseph Desch designed specific memory that automatically reversed itself and returned to the correct position. Another big improvement on this machine was that they actually can print the answer, which is a big deal. So, and this is some wonderful information, I'm just like very excited by what I read it, that the average delay in breaking the code was about 12 hours, okay? But it also meant that if Germans send the information or send the communication in the afternoon, the Americans could read it right with them at the same time. That's what it was. That's how accurate, how amazing that was. I was okay. Now, make no mistake, these were the heroes, these were the people, the American ways of officers, enlisted men, working at Dayton, Ohio factory, like I said, 24/7, for months and months and months on end. And this was the team, HUT 26 in headquarters. As you can see, officers, waves, and civilian working together to accomplish that mission. So, just gives you some idea. But, as amazing and astounding that story of breaking the code is, I only touched on some highlights. The stories of all the other theaters, of all the people in all the boardings, all the little changes they were making are astonishing. It was an army of heroes. And the most important thing is that they all kept a secret, which is absolutely astonishing. Because they were under strict audit during World War II, but even after the end of war, they were not talking about it. So it's not till 1974 that the first information about that whole process begins to appear. And as you've seen, this process, this code-breaking process, was incredibly difficult, spanning years, continents, thousands of people, and very difficult. But there is no denying that they also got some help from the fallibility of human nature. Making mistakes is what makes us human. And to this hubris, greed, laziness, habits, and unbreakable can be broken. Throughout my presentation, I alluded to that, briefly on this and that, starting when Hans Tyler Schmidt breed and selling of the information to the French. Then the design of the rotors in order, alphabetical order, sending the first 3 letters twice, in plain language using the series, a quirk in the rotor that allow for females, not spinning the wheels properly each morning to randomize the positions of the wheels. That's the first 3 letters of secret code were undecoded. And finally, the German military high command, complete failure of imagination, and total belief in infallibility of the Enigma machine. Each of those added up to making that job a touch easier for Polish, British, and American cryptanalysts. At the end of my presentation, I just point out to a few movies that were made about the Enigma machine. Although Imitation Game is terrific and features Alan Turing, none of them can truly capture the scope and the complexity of that whole code-breaking mechanism. This is astonishing. And also there are some terrific books. I particularly like this one by Montego. Fantastic book. I mean, there's so much information. I just like, if you were trying to make a fiction, it's better than fiction, honestly. You cannot make things up, what was actually happening during that process. So it's hard because there are not enough visuals to show you, but in the museum, we have a fantastic exhibit of the coding Enigma machine. We have a terrific video that I couldn't bring, which is a few minutes long, that truly shows you, walks you through the process, how they coded it, that machine, and then how the coding occurs. So if you haven't been to the museum just for the Enigma machine, it will be very worthwhile for you to take a quick look. And also I handed out our brochure, and as an incentive, there is a 10% discount card for our gift store. So, like I say, it's not an easy subject. I'm sure I missed a lot. But I just wanted to give you an idea of complexity and the human ingenuity in trying to reach and decode the net. So thank you so very much. Can I take questions? Okay, I'll take a few questions. No guarantee I'll answer, but go ahead. Yes, please.
What happened to the three Polishmen?
You know what, that was very complex. That was actually a very sad story. You know, it took them a long while to escape Poland. You know, they went through Algeria and then somehow they were not allowed, or they could not cross to England, so like in France. They were actually in French cryptography offices. And so one of them, Różycki, died very young because he was, one of his boats he was on during World War II was sunk. Henry Żygalski stayed in England and was a mathematics professor in London. And Henry Rejewski returned to Poland and passed away like in the 80s. So, but again, at this time they were still keeping those secrets, although I don't know how. I grew up in Poland and I knew about it. So don't do it. So yes, that's what happened to those cryptanalysts. No? Yes.
Besides putting their rotors in alphabetical order, the Germans apparently from your pictures used Roman letters too.
Yes.
Even though in Germany they were still writing in that old Fraktur style. So that made it easier for...
That's a very good point. That's a very good point, yes.
I just did some research on that, and it was 1941 when the Nazis decreed that Fraktur style type was no longer to be used.
Okay.
So back there in the 20s and 30s they were using the Roman letters, which made it easier
Yes.
for everybody.
Sure. Sure. Great point. Thank you. Yes.
Looking at breaking the code of the enemy, in that case the Germans, did the United States or England have a cryptology system that was not broken or was broken by the Germans?
You know what? Not really. You know, because they were, you know, they had different codes. But I haven't heard. There is no story anywhere that I came across.
I would say the only unbreakable code from World War II was
The Navajo.
code talkers.
Code talkers, yes. That's of course Navajo. Navajo code, nobody could break it. Nobody could break it. So that's another fascinating story because they use it particularly in Pacific.
Right.
So that's where they were using it. I should do more research, but I haven't heard of American or British codes broken. No, there was a loss of information, but that's to people, spies. So anything that you get, you know, that they lost, it was human. They were spies, or double spies. So yeah, that was a big problem on both sides. Huge problem. Yes.
So how long did they use this technology then? You said it was not.
You know, it's funny you should ask, you know, because they kept it secret. They actually used, after World War II, Germany, you know, completely stopped using it and the machines were lost. But Americans used it for quite a while. Yes. Okay. Yes.
Have you ever read Code Girls?
I'm sorry?
Code Girls?
Yes, you know, women were absolutely paramount in this whole process. I mentioned waves. Women were so much involved, you know. Like I said, I could not even touch how complex that whole system was. Even in the movie Invitation Game, although they show Turing and how he discovers it, it looks like there's maybe a few hundred people working, right? There were thousands of people working. You know, they were listening to those messages. And the women were so attuned that they could actually know which operator was sending the message by the Morse code. So that's, and you know, women were behind all of these processes.
Yeah, but Code Girls is a really good.
Yeah. Mm-hmm.
It covers more than just Enigma.
Yes. Yes.
So did the enemy, the Japanese and the Pacific Theater, did they have something like Enigma machine?
Yeah, they did have the purple, and that wasn't really quite decoded. That wasn't quite broken. They had a different system, yes. So, like I said, Pacific was different. There was just like, this was Atlantic and Mediterranean. Because they, of course, were in the Mediterranean Sea too. And then north. Okay. And Maury, I'm so happy you came. I just want to bring it up because Maury was in Merchant Marine. And so, you know, it's just like so amazing to see it and see this connection. Thank you for coming, Maury.
My pleasure. Thank you.
Thank you. Okay. Anything else? Well, thank you so very much. And you've been patient. This was Maury.